हेलो बच्चों, तो आप सबका स्वागत है शौर्य एकेडमी इस यूट्यूब चैनल में। तो आप पढ़ने जा रहे हो फिजिक्स विद वैभव सर। लेट्स गेट स्टार्टेड।
So hello बच्चों, so today we are going to revise the formulae on rotational dynamics, correct? So चलो first start करते हैं quick formula revision on the rotational dynamics. So first formula is what? Angular displacement. ऐसा ही है? So what is angular displacement? Now see कि बाबा आपको मालूम है, suppose particle performing the circular motion. Correct? So यहाँ से particle, suppose this is the what? Original position. After certain time particle goes to point Q. Correct? So it covers the angular displacement theta. Then this is the ds and the radius of circular motion is r. Then what is the relation? Yes, that is delta theta angular displacement is equal to delta s upon r. ऐसा ही है? So आपको मालूम है what is the unit of this? Yes, unit क्या होता है एंगुलर डिस्प्लेसमेंट का? It is measured in radians. ठीक है? Now next बच्चों, angular velocity. क्या होती है angular velocity? Now angular velocity is represented by omega. Omega is instantaneous angular velocity is d theta upon dt. That is, you know that limit delta t tends to 0, delta theta upon delta t. Okay, what is its unit? Yes, unit of angular velocity is radian per second. The next second formula that is used, omega is equal to 2 pi upon t. T is the time period of revolution or rotation, that is the time required to complete the one rotation. Then in terms of frequency, omega is equal to 2 pi f. Correct? This is formula to calculate the angular velocity. Next one is what? Angular acceleration. So omega is the rate of change of angular displacement. Similar to that, angular acceleration is a rate of change of angular velocity. So we can also write that is alpha is equal to limit delta t tends to 0, delta omega upon delta t. Is it clear? What is unit? Yes, unit is radian per second square. Okay. Now next, one more relation we know that ki linear relation between the linear velocity and angular velocity, that is what? V is equal to r omega. Okay. And similarly, here you know that tangential acceleration is r into alpha. Linear velocity, then tangential acceleration, and this one. Is it clear? Okay, now this is about the what? Angular displacement, angular velocity, angular acceleration. Okay, next. Centripetal force, centrifugal force, we know that whenever the body is moving on a circular path, it experiences the what? That is the one force which is acting towards the center along the radius is called the centripetal force. Correct? Similarly, now r is the radius of circular path. Correct? So we know that which are the different formulas. Centripetal force is equal to mv square by r, then mr omega square, then mv omega. Lekin if you consider the direction, then it is what? Minus. Why? Because position vector which represents the position of particle, it is away from the path, that is acting along the radius away, and centripetal force is acting towards. That's why by sign, that is vector form, it is minus. Centrifugal force, it is the what? It is the pseudo force. Centripetal force is a real force, and this pseudo force is experienced in the non-inertial frame of reference. You have studied the two frame of reference. One is the inertial frame of reference, means where the body is at rest or moving with uniform velocity, that is acceleration is constant or zero, and the non-inertial frame is called the accelerated frame. Correct? So Newton's laws of motions are only applicable in the inertial frame of reference. Is it clear? Matlab, if you're talking about the formulae, both are same, only the direction here is the what? Positive mv square by r, mr omega square, and mv omega. Clear? Second one, now see, centripetal force produces the centripetal acceleration. Correct? So centripetal acceleration is also called the radial acceleration. Its direction is towards the center. Means if you're talking in the same diagram, this is the direction of what? Centripetal or the radial acceleration. Second one is a what? Tangential acceleration. Centripetal acceleration produces the rotation. Tangential acceleration gives the velocity. Clear? So, both acceleration you find centripetal and tangentials are perpendicular to each other. So, what is the formula to calculate the centripetal or radial acceleration? It is, yes, V square by R omega square or the V omega. Tangential acceleration is what? dv by dt, or already in the previous slide we observed at is equal to r into alpha. And now resultant acceleration, now you know that resultant is find with the help of, that is the total acceleration, root of ar square plus at square plus 2ar at cos of theta. But angle between the centripetal and the tangential acceleration is 90. That's why what is the formula to calculate the total acceleration? It is ar square plus at square. Now one more thing, remember that two types of motion. One is a uniform circular motion, second one is a non-uniform circular motion. In case of uniform circular motion, the particle is moving along the circumference of circle with constant speed. That's why at is 0. Whenever we are talking about the UCM, at is equal to 0. Means this formula is for what? Non-UCM. Both acceleration are present. And whenever talking about the total acceleration is equal to radial acceleration or centripetal acceleration for uniform circular motion. Any doubt? Okay. Next. The maximum speed of the vehicle moving on a horizontal curve road. So if you remember, I am considering this horizontal surface, vehicle is moving, correct? On this horizontal surface along the curve path, suppose I am considering like this. So we know that different forces are what? The weight of the vehicle acting, then it is balanced by the normal reaction exerted by the surface. Then here it is the what? Yes, it is the frictional force. Is it clear? Correct? So we know that by considering this free body diagram, we derive the equation which is the what? V is equal to root of mu s r g. This is the what? Condition of maximum speed of the vehicle on the curved surface. So mu s is the coefficient of static friction, r is the radius of circular path, g is the gravity. This is the condition of what? Maximum. Clear? Next, well of depth. Now we know that well of depth is what? Just consider that is a cylindrical like this path. The vehicle is moving along the circumference of this cylindrical path. So if you consider the position at a particular point, so different forces acting on the that is weight is acting in the downward, which is balanced by, now in this case, the friction surface. Then force exerted by this, that is a normal reaction, is acting towards, and this one is the what? The radius of circular path. Okay. Now in this case, we derive the equation of what? Yes, that is the minimum speed of vehicle moving along the what? Circumference of circle, that is inside the well of depth. So what is the formula? V minimum is equal to root of Rg upon mu s, same radius g, coefficient of static friction. Now in this case we derive the formula for what? That is the V minimum. Okay. Now next, bank road. So in the bank road, if you remember the diagram, yes, we have considered the what? That is the road, outer edge of the road is inclined with respect to inner edge by certain angle, is called the angle of banking. So this is the theta. This one is actual the road surface. Now vehicle is moving on this, that is like this. Correct? So in this case the different forces are acting what? The weight mg is acting downward. Then normal reaction exerted by the road surface, which is acting like this. Now this angle is theta, so you know that ki baba, this is vertical component inclined at theta, this one is the what, moving towards the center. Correct? Now this component is resolved into two, this n into n cos of theta, and this component is a n sin theta. So we have solved the two equations. First equation you are getting, if you remember, that is n cos theta is equal to mg, and second equation t sin n sin theta is equal to centripetal force. Clear? And then we derive first formula. What is the first formula? Most sap speed. That is what? V is equal to root of Rg tan theta. Theta is called the angle of banking. R is again radius of circular path. Okay. The next one is what? Angle of banking. From the same equation we can write theta is equal to tan inverse of V square by Rg. This is the formula to calculate the angle of banking. Then we again derive the equation by consider the frictional force in addition to that. What is the upper speed limit and the lower speed limit? So first formula is for what? That is upper speed limit, that is a V max. Formula is what? Root of Rg in bracket tan theta plus mu s upon 1 minus mu s tan theta. Then V minimum is what? Root of Rg in bracket tan theta minus mu s upon 1 plus mu s tan theta. So mu s is again coefficient of static friction, all the other parameters remain same. Correct? So these are the formulas related with the bank road, most sap speed, angle of banking, upper speed limit or maximum speed, lower speed limit or the minimum speed. Okay? ठीक है. The next, conical pendulum. Okay? Now again if you observe the conical pendulum, we know that ki baba, yes, the heavy mass which is called the bob is attached to the long, massless, inextensible string. It's called the pendulum, and whenever this pendulum is moving in a or revolving in a circular path, it forms the right circular cone at the fixed end support, so that is called the conical pendulum. So means what? It performs the what? Circular motion in the horizontal plane. Correct? So yahan se, now see, so we know that again if you are observing the force analysis, this is one is what? Mg, then the tension is acting through the string, its vertical angle is the what? Made by with the vertical is the theta, then you know that this tension is resolved into two components, one is T cos theta, second one is T sin theta. Clear? From this, now again we derive the equations. First one is what? The time period of conical pendulum. But यहाँ से remember, one more formula is required जो आता है, that is R is L sin theta, where L is what? It is the length of the string. So correct? Small r, that is the radius of circular path, is L sin theta. Clear? Okay. Now, from this we derive the first formula, that is what? Time period T is equal to 2 pi root of L cos theta divided by G. Clear? L is the length of string. Theta is the angle made by the pendulum with the vertical. Frequency is a reciprocal of time period. So what is the equation of frequency? 1 upon 2 pi root of G upon L cos theta. Okay. Now, next is a what? Sphere of death. That is the when the vehicle is moving over the convex bridge. Okay. So we know that here is the center. This distance represents the R. Now, when the vehicle is at the top of this convex over bridge, if you are observing the formula, this weight mg, then normal reactions. Now here you derive the equation, that is the V minimum is root of Rg. Yes, the minimum speed whenever the vehicle is moving inside the sphere of death or at the top surface of convex breach, the minimum speed is root of r. R is the radius of this. Clear? Okay. Next, the vertical circular motion. Now there are the two motions. One is a controlled vertical circular motion and second one is a non-controlled. So non-control is also called, if you remember, this is also called the motion under a gravity which is controlled by the gravity. So diagram, now you know that we are considering it is a what vertical circular motion. We are talking about the what, that is one mass is attached at the end of the string. Okay, so we are considering this is the what, length of string. Length of string is nothing but the radius of vertical circular motion. Okay, so we have considered the three positions. This one is the what, topmost position. This one is the what, lowermost or bottom position. These are the what, horizontal positions, C and T. Correct? So in this case, you know that weight is acting in the downward, tension is acting towards the center. Whenever we comes to the point B, weight is acting downward, tension is acting, now tension at each point is different. So here the TA, here is the TB. In this case, tension is acting towards, that is the TC, that is a TD. Okay, then we are considering the what. Now see the formulas. Basically, first formula is of what, at topmost position we are considering the tension is 0. What is the equation of tension? If you remember, that is TA plus mg is equal to mVA square by R. The next, third formula, V minimum at position A. What is the minimum speed of the particle at point A to perform the vertical circular motion? It is root of Rg. Then we come to the middle position. In the middle position, we know that tension is acting towards the support. So just remember that the TC, which is equal to TD, is equal to mVc square by R. Correct? Because the net force towards the center is the tension, which is balanced by the centripetal force. And what is the minimum speed at horizontal position to perform the vertical circular motion is root 3 Rg. Then we come to the lowermost position, that is the point B. So we know that first equation, what is the equation of tension now? The tension at point B is equal to S, that is mg plus mvb square by R. Okay, and the minimum speed at point B to perform the vertical circular motion is root 5 Rg. And one more, the tension between the uppermost position and the lowermost position, it is the what, TB minus TA, which is equal to 6 mg. That is, tension is maximum at the lowermost position and the minimum at uppermost position. Speed is maximum at the lowermost position, speed is minimum at the uppermost position. So these are all the formulas regarding the vertical circular motion. Okay? ठीक है. Next. Now, moment of inertia. Okay, that is the resistance to body performing a rotational motion. Correct? Inertia means the resistance, opposition. So, we know that we are considering first formula is for discrete body that can be divided into number of particles, and second one is for continuous body. So what is the formula? The formula is what? That is, here the I is equal to summation of mi ri square, where I start from 1 to n. Is it clear? Okay, and second one, for continuous body, moment of inertia is integration of r square dm, means which cannot be divided into finite number of particles. And second thing, we know that is the one formula, I is equal to mk square, where k is called the radius of gyration. We are considering the total mass of body is to be concentrated somewhere. That point is the center of mass, and the k is the distance of the axis of rotation from the center of mass. Okay. Then what is the unit of moment of inertia? It is kg meter square. Okay. Next is what? Radius of gyration. From this formula, I is equal to mk square. What is the formula to calculate the radius of gyration? That is k is equal to root of I by m. Okay. Then theorem of parallel axis. We know that if we consider the body, correct, there are the two axes. When we are considering the moment of inertia about an axis passing through its center of mass, and if you want to find out the moment of inertia about any axis which is parallel to the given axis, suppose I naught, then we are considering the perpendicular distance between the two axes, that is the h, m is the mass of the body. Then what is the parallel axis theorem? That is moment of inertia about any axis which is equal to sum of moment of inertia about an axis passing through its center of mass parallel to given axis plus product of mass of the body and the perpendicular distance between the two axes. Okay, so I naught is equal to IC plus ms square. Now theorem of perpendicular axis, that we are considering the planar lamina. Correct. First condition is what? This theorem of perpendicular axis is only applicable to laminar objects. Correct. So here we are considering the z. Now this one is suppose x and y. Okay. So we know that what is the perpendicular axis theorem? That is I of z is equal to ix plus iy. Means what? The moment of inertia of laminar body about an axis which is perpendicular to lamina is equal to sum of moment of inertia of the two axes which is in the plane of lamina, and all the three axes are congruent, that is passing through same point. Okay, now this is the equation for perpendicular axis. Okay, now next, the torque acting on rotating body in terms of moment of inertia. So what is the formula? Yes, the formula is torque is equal to I into alpha. Moment of inertia, alpha is the angular acceleration of rotating body. Clear? What is unit? Newton meter. Second formula you also know. What? Baba, torque is equal to R bar cross F bar. ठीक है, and one more is there that we are studying the next, that is law of conservation of angular momentum. वहां से मैं फॉर्मूला वहां पे ही लिखता हूं. ठीक है, नीचे ही है. हाँ, rotational kinetic energy. What is the formula? Kinetic energy of rotating body, it is ET is equal to half I omega square. करेक्ट. यहां से खाली सिंबल में चेंज करो, रोटेशनल तो मैं यहां पे ई लिखता हूं. सो काइनेटिक एनर्जी ऑफ रोटेटिंग बॉडी इज इक्वल टू हाफ आई ओमेगा स्क्वायर. Then angular momentum in terms of moment of inertia, formula is what? L is equal to I omega. Second formula क्या होता है? L is equal to R bar cross P bar is equal to mvr. Okay, and what is the unit of angular momentum? Yes, it is kg meter square per second. Kg meter square per second. Now next, what is the conservation of angular momentum? That is angular momentum remains constant. लेकिन law क्या कहता है? In the absence of external torque, the rate of change of angular momentum remains constant. Torque क्या होता है? dl by dt. Okay, so in the absence of torque, matlab torque external is equal to 0, then angular momentum remains constant. So what is the formula of angular momentum? It is the I omega. So from this we can write, that is I1 omega 1, I2 omega 2. Omega is 2 pi of frequency, so we can write I1 F1 I2 F2. If it is given in terms of time period, I1 upon T1, I2 upon T2. So this is the law of conservation of angular momentum. Okay, so okay. So this is about the what? Torque, rotational kinetic energy, angular momentum, and the conservation of angular momentum. Next, the formula to calculate the rolling kinetic energy. Okay, so for that we have considered the inclined plane, which is an incline at angle theta with respect to horizontal. Body is moving from the what at topmost to bottom position. During this, it travels the displacement, that is a s. Then height is equal to s sine of theta. This h is equal to s sine theta. Okay. Now in this case we are considering the pure rolling motion, means without any friction, no means what? Body performing pure rolling motion. Now we have to find the first formula, rolling kinetic energy. So we know that the kinetic energy of rolling is equal to kinetic energy of translational, kinetic energy of rotational. Okay, so from this we are getting the three equations. First one is a what? That is kinetic energy of rolling. We can substitute translational kinetic energy as a half mv square, rotational kinetic energy as a half I omega square. Then we are using the relation, that is the what? I is equal to mk square and v is equal to r omega. We obtain the second equation. That is what? Rolling is equal to half mv square in bracket 1 plus k square by r square. And to derive this equation, further we have to derive the equation of velocity and acceleration. We are applying the law of conservation of energy, that is the body initially having the potential energy converted into rolling kinetic energy. So we can also write Baba mgh, that is potential energy, is converted into rolling kinetic energy, means 1 plus k square by r square, by using the law of conservation of energy. Now by using this we obtain the equations of velocity. What are the equations? V is equal to root 2gh upon 1 plus k square by r square, and the acceleration is equal to g sine theta upon 1 plus k square by r square. Okay, so these all are the formulas related with the body performing rolling motion on the inclined surface. Okay, the next. Now next one more thing can be asked, ratio of translational kinetic energy to rotational kinetic energy to rolling kinetic energy, and what is the formula to calculate this? It is, yes, 1 as 2, yes, k square by r square plus 1 plus k square by r square. And now we already observed the different shape of an object, and for this the value of k square by r square. If you remember, first one is we are considering for the what? Yes, the ring or hollow cylinder about the central axis. So this value is what? It is the 1. If you consider for the disc or solid cylinder about the central axis, it becomes 1 by 2. If you consider the solid sphere, it becomes 2 by 5, and if you consider the hollow sphere about its diameter, then it is 2 by 3. Okay, so from this we can find out the ratio of translational to rotational to kinetic. And if you are asked to find out the shape, then we are finding out the value of k square by r square, and then we are going to find the shape of the object from the value of k square by r square. The next. Now linear kinetic equations and correct, rotational kinematic equation. So we know that first equation is what? V is equal to U plus AT. S is equal to UT plus half AT square. V square is equal to U square plus 2AS. Final velocity, initial velocity, linear acceleration, time, S is the displacement. So we are considering, suppose same equation can be replaced for the rotational. So V Yes, it is omega 2 is equal to omega 1 plus angular acceleration into time. Then theta is equal to omega 1 t plus 1 by 2 alpha t square. Then omega 2 square is equal to omega 1 square plus 2 alpha theta. Replace the corresponding parameters. Okay. The next, and one more thing, formula, if you remember, if you want to ask to find the number of revolutions, you substitute the theta is equal to 2 pi into n, because in one revolution it covers the 2 pi radians, so into theta. Now see, next table is of what? Key important conditions I have taken. There are many more conditions. First, the object, then axis, moment of inertia about which axis, whether it is a central or about its diameter, and the radius of gyration. So first shape is what? Thin ring or the hollow cylinder. Central axis mr square, k is equal to r. Second, thin ring, lekin about diameter, so it becomes mr square by 2, then it becomes r by root 2. You know that how to calculate the radius of gyration? You have to equate the moment of inertia equation with the mk square, and then you are going to find the k. Then uniform disc or solid cylinder, about central axis mr square by 2, r by root 2. Again about the diameter, for the disc it is mr square by 4. Then solid sphere, about its diameter or the central axis 2 by 5 mr square, then again root 2 by 5 r. For hollow sphere it is central 2 by 3 mr square, root 2 by 3 r. Then thin uniform rod, about central axis ml square by 12, l by root 3, l is the length of rod. About one end you can add, it is ml square by 3. Clear? So these all are the formulas from the rotational dynamics. Any doubt?
तो बच्चों, अगर आपको मेरा वीडियो पसंद आया है तो डू नॉट फॉरगेट टू लाइक, शेयर एंड सब्सक्राइब. तो पढ़ते रहो फिजिक्स विद वैभव सर.